In this video, we will go over another integral problem type. This problem will involve partial fractions, and I'm calling it a type 2 repeated linear factor. And so if you want, you can pause the video here and attempt this problem. So unlike the last video, which was a partial fraction for distinct linear factor, this one has a repeated linear factor. And I'll tell you what I mean by that. So here we have an x plus 4 and it's squared. And because it's squared, we need to do something different. So we will say equal a divided by x, because we have an x here, plus b divided by x plus 4, plus, because it's squared, we need to repeat it, c divided by x plus 4 squared. And so this is the form that we get. And the next step, we would multiply by the common denominator, which will be x times parentheses x plus 4 squared. And so we get x squared plus 16 is equal to a times parentheses x plus 4 squared. And this is because this term has an x, and here we have an x, and so they cancel. And so we're left off with x plus 4 parentheses squared plus b times x plus 4 plus c times x. So next we can expand. So x plus 4 squared is x squared plus 8x plus 16. And then x times x plus 4 would give us x squared plus 4x. And next we can also expand, so a times x squared plus a times 8x plus a times 16 plus bx squared plus b times 4x plus cx. And now we will group. So we're going to group the x squared terms, the x terms, and the constant terms. So we would get x squared times parentheses a plus b, close parentheses, plus x. Then we would have 8a, 4b, and c, close parentheses, plus 16a. And on the left-hand side, we had x squared plus 16, but we also had a 0x. And so now we can say that 1 is equal to a plus b, because x squared is 1x squared, and here we have x squared parentheses a plus b. And so 1 is equal to a plus b. Likewise, 0 is equal to 8a plus 4b plus c. And finally, 16 is equal to 16a. And so we know that a is going to equal 1 because 16 is equal to 16a. Next, we will solve for b because 1 is equal to a plus b. We know a is 1, and so b would equal 0. And finally, we'll say that 0 is equal to 8a plus 4b plus c. And we know that a is 1, so we get 8 plus 0 plus c. And so c is going to equal negative 8. And now we will solve this integral here. 1 divided by x plus 0 minus 8 divided by parentheses x plus 4 close parentheses squared dx. I'm simply replacing the values here. So a was 1, b was 0, and c was negative 8. And so one more step that I will do, instead of saying this, I could say negative 8 parentheses x plus 4 raised to negative 2. They're equivalent. And now we will get the integral of each piece. So 1 divided by x would give us ln absolute value of x minus 8 divided by negative 1 times parentheses x plus 4 raised to negative 1 plus c. And so this is what we would get as our final answer. And that's all we need to do for this type of problem.